In this lecture, I am going to explain the two problems which are asked in 2005 and 1990 MEC paper. So these are the two problems. So this question was asked in 1990 GATE, and one more question is asked in 2005. Okay, first I'll solve this. The transfer function of a closed loop system. That is, he has given the closed loop system. Okay, this is not open loop system, it is a closed loop system. And where k is the forward path gain, it's fine. And the root locus plot of the system is, he asked the root locus, right? He asked the root locus, not the complementary root locus. He asked the root locus, right? And he has given closed loop transfer function. It's not an open loop transfer function. We draw root locus for open loop system, right? So now here the transfer function given k by s square 3 minus k s. What is the characteristic equation? What is the characteristic equation? Denominator term. What is the characteristic equation of a transfer function? The denominator, right? S square plus 3 minus ks plus 1 equal to 0. From this, 3s minus ks plus 1 equal to 0. I will make this s square plus 3s plus 1 common. S square plus 3s plus 1 equal to 0. From this, 1 minus k s by s square plus 3s plus 1 equal to 0. So I will compare this equation with 1 minus k gs hs equal to 0. From this, gs hs open loop gain, that is s by s square plus 3s plus 1. And from this, zeros, s equal to 0 is a 0 of a open loop system, and two poles are there, two open loop poles. To calculate the poles, you will get minus 2.62 and minus 0.38, right? These are the open loop poles. That is, number of open loop poles are 2 and the number of open loop zeros are, and p minus z equal to 1. I will find out angle criterion, right? Here a gs hs equal to 1, right? Now a gs hs equal to 1, and in the question he asked to draw a root locus plot, right? This is root locus. What is the definition of the root locus? The gain k should be varied from 0 to infinity. This forward path k should vary from 0 to infinity. That is, here the k is positive. So we are varying from 0 to infinity, that is positive. So if k is positive, then what is the angle? 0 degrees or 360 degrees or even multiples of 180 degrees. If the angle criterion is even multiples of 180 degrees, the rules, right? The rules to draw the complementary root locus or root locus, those will be going to changed. So what are those changes? So first I will explain those changes here. Suppose this one, suppose this angle criterion is odd multiples of 180 degrees. The first point, here the first point, to exist a root locus or a complementary root locus at a point on the real axis, there must exist odd number of open loop poles and zeros to the right side of that point. Okay, so there must exist odd number of poles and zeros to that point, to the right side of that point. But in the case of this one, even multiples of 180 degrees, if the angle criterion is, then to exist root locus or complementary root locus at a point on real axis, there must exist even number of open loop poles and open loop zeros to the right side of that point. So here even number, right? Now the second point is angle of asymptotes. The angle of asymptotes is 2q plus 1 180 by p minus z, where q is from 0 to p minus z minus 1. Here the angle is theta a, 2q 180 degrees by p minus z. Right? This is angle of asymptotes, and few more points are also going to change. So these 2 points. Angle of departure. So in this case, it is 180 plus angle of G of S H of S at S equal to pole. In place of 180, we have to substitute 0. Similarly, here also, in place of 180, we have to substitute 0. That's it. Angle of departure and angle of arrival. These are the 4 points going to be changed because these 4 points are derived from the angle criterion. The remaining points, the remaining rules are derived from the magnitude criterion. So because of that, but in these two cases, magnitude is 1 only, right? 2q 180 degrees, angle criterion. So, and root locus, root locus k 0 to infinity. That is, at k equal to 0, it starts at open loop pole, right? At k equal to 0, pole exists. That is open loop pole. This is the starting point. And ending point at k equal to infinity, open loop 0 exists. That is ending point. So the root locus the root locus starts at open loop pole and ends at open loop 0. Root locus will represent these things. So what are the poles? Minus 2.62 minus 0.38 minus 0.38 minus 2.62 and s equal to 0 is a 0. This is 0. Right? So on the real axis, how will be the root locus? So here the angle criterion is even multiples of 180 degrees. To exist a root locus or complementary root locus on a real axis, there must be even number of poles and zeros to the right of that point. So here in this region, to the right of this region, we have one pole and one zero. That is 2. Sum is 2. And here also root locus exists because to the right of this point, there are no poles and zeros. The number is 0. You can take the 0 also, the 0 also a even. So this is real axis segment. Poles minus zeros. Number of poles minus number of zeros is 1. So that is only one asymptote exists. And what is the angle of asymptote? It is theta a. What is the angle of asymptotes? Theta a is 2q 180 degrees, right? In case of even multiples of 180 degrees, p minus z, q from 0, 1, 2 up to p minus z minus 1. So what is p minus z here? 1. 1 minus 1, 0. So only q equal to 0 only exists. So substitute q equal to 0, you will get 0 degrees. Okay. So this theta a equal to 0 is a angle of the asymptote. Only one asymptote exists, and that angle is 0 degrees. So one root locus branch will move to infinity through this asymptote, that is with the angle 0 degrees. So this is 0 degrees. Break in breakaway points. How to find out the break in breakaway points? From this equation. So 1 minus k GSH is equal to 0 from this equation. What is k here? K equal to s square plus 3s plus 1 by s. That is s plus 3 plus 1 by s. Now, so k equal to s plus 3 plus 1 by s dk by ds equal to 0. That is 1 plus 0 minus 1 by s square. So s square equal to 1. From this s equal to plus or minus 1. Plus 1 and minus 1. Two break in breakaway points obtained. So whether they are valid or not, I'll represent first them. S equal to minus 1. So minus 1 will be here, somewhere here. So not a pole. Here minus 1 and plus 1 somewhere here. Right? And these two are valid break in breakaway points. Why? Because these are lying on root locus plot, right? Because of these break in breakaway points lie on root locus plot. These are valid break in breakaway points. Now, so from this information, I will draw a root locus because at s equal to minus 1 and s equal to plus 1, break in breakaway must exist. So for that, and the root locus starts from 0 to infinity. That is, k equal to 0, we have open loop pole, and k equal to infinity, we have open loop 0. So here, here the k equal to 0, here the k equal to 0 at these poles, and at this 0, k equal to infinity. Okay, and these two poles have to meet here because break-in exists at s equal to -1, and breakaway also exists at this point, right? So this pole will move here, 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 and here also break-in exists, and here also break-in exists. Once they break in at s equal to 1 and break away, and one pole will move to this 0 and another pole will move to infinity through this asymptote, 0 degree line asymptote, right? That's it. This is the root locus plot. And now I have to find out the gain k at some points. At poles k is 0, at 0 k is infinity, but I will find out the gain k at this point. So this is the point on j omega axis, and at this point on j omega axis, and at this points, that is at s equal to -1, here at s equal to +1. What is k? What is k? How to find out? So these gains are find out by using, and these gains are find out by using the magnitude criterion. What is magnitude criterion? Here. So 1 minus k s by s square minus 3s plus 1 equal to 0, equated to 1. 1 minus k by s square plus 3s plus 1 into s equal to 0, k s by s square plus 3s plus 1 equal to 1. Magnitude. So make magnitude both sides. I'll get 1. So if you want to find out magnitude at s equal to -1 and magnitude at s equal to +1, just replace s by +1 and -1. At s equal to -1, k into -1 by 1 minus 3 plus 1 equal to 1. And you get k equal to, so at s is equal to -1, k is 1. And at s equal to +1, k into 1 by 1 plus 3 plus 1. And k equal to 5 at s equal to +1. And at s equal to exactly on j omega axis, right? At these points, what is k? What is k? Here also, what is k? And also, what is this point? This is j omega line, right? This is real axis. What is this? That point? What is that omega here? What is that point? So we'll find out this from RH criteria. So j omega crossings are founded by RH criteria. So for RH criteria, we need characteristic equation. What is the characteristic equation here? This one. S square plus 3 minus k into s plus 1 equal to 0. Now characteristic equation, s square plus 3 minus k into s plus 1 equal to 0. RH criteria, RH table, s power 1, s power 0. This 1, 1, 3 minus k, 0. Here 1. So on j omega axis, right? On this point, on j omega axis, the system becomes marginally stable. Below j omega axis, that is to the left of j omega axis, the system is stable. To the right of j omega axis, the system becomes unstable. But on j omega axis, the system becomes marginally stable. Because it is marginally stable on the system, on the j omega axis, this s power 1 row becomes 0. That is, this 3 minus k row must become 0. So from this, k equal to 3. What is that point on j omega axis? This is gain at that point. What is that point also? I'll find out that point from auxiliary equation. This is auxiliary equation. s square plus 1 equal to 0. From this, replace s by j omega, that is minus omega square plus 1 equal to 0, omega equal to root 1, that is 1. So omega is 1. So here j omega x is right, this is plus j1 and this point is minus j1, is minus j1. And what is the gain here? Here the gain is 3. Here also the gain is 3. Here the gain, we got gain k equal to 5, and here the gain we got k equal to 1. Right? That's it. This is the root locus. This is the question. Which option is correct here? And option B. Right? Option B is correct. And here we have not drawn complementary root locus. We have drawn only root locus. Right? He has not asked complementary root locus. Next, I will explain the second question. This one. An unity feedback system is given as GS K1 minus S by S into S plus 3. Indicate the correct root locus diagram. So he has mentioned only feedback system, right? So he has not mentioned anything about positive or a negative. So if nothing is mentioned, must be negative feedback system. Okay? So if it is a positive feedback system, you will specify it in the question, right? If nothing is mentioned, we have to take it as a negative feedback system. Now here also he asked root locus only. So this is root locus. He has not asked complementary root locus. Anyway, I will draw complementary root locus also for this question at the end. So I will draw root locus for this. Now, GS is K1 minus S by S into S plus 3 and is given unity negative feedback system S into S plus 3. So from this characteristic equation is 1 plus K 1 minus S by, what I do, 1 minus K S minus 1 by S into S plus 3 equal to 0. And from this 1 minus K G of S H of S equal to 0. I'll compare this. So from this, the open loop poles are 0 and minus 3 and open loop 0 is 1. So number of open loop poles are 2 and number of open loop zeros are 1. P minus Z is 1. That is number of asymptotes are 1. And from this equation, so here 1 minus K Gs Hs equal to 0. This is the equation. Now from this K Gs Hs equal to, again we are getting plus 1, right? And we are drawing root locus for this. This K Gs Hs equal to plus 1, and we are drawing a root locus. Root locus means the definition is the forward path gain must be varied from 0 to infinity. That is, K is positive here. If K is positive here the K is positive. That is plus 1. Here also plus 1 is there. So you will get 0 degrees or even multiples of 180 degrees. If angle criterion is even multiples of 180 degrees, then the rules which are associated with the angle criterion are going to be changed. T minus Z equal to 1. That is, one asymptote exists. And what is the angle of asymptotes? 2P into 180 degrees by P minus Z. That is 1. And Q from 0 to P minus Z minus 1. That is only 0. So substitute 0 here, you will get 0. So here we got the angle of asymptote is 0 degrees. And break-in breakaway points, I'll find out here itself. Break-in breakaway points. Here 1 minus K S minus 1 into S plus 3 equal to 0 from this. So 1 equal to k into s minus 1 by s into s plus 3. This k here, s square plus 3s by s minus 1. dk by ds equal to 0. From this you will get breakover points. S minus 1, 2s plus 3 minus s square plus 3s into 1 by s minus 1 whole square equal to 0. Right? From this 2s square plus 3s minus 2s minus 3 minus s square minus 3s equal to 0. Right? S plus 3s minus 3s 1. 2s square minus s square minus 2s minus 3 equal to 0. From this s square minus 2s minus 3 equal to 0. What are the roots here? Roots here equal to minus b plus or minus b square minus 4ac by 2a. 2 plus or minus 4 by 2. 6 by 2 minus 2 by 2. These are the two roots. These are two breakaway points. 3 and minus 1. Right? So these are breakaway points. So whether these are valid or not, we will find out. Now I will draw. And this is 0 degree line. So this also asymptote also is 0 degree line. And real axis. This is imaginary axis, j omega axis. Now we represent the poles and the zeros. So what are the poles and zeros? 0 and minus 3 are poles. 1 is a 0. 0 and minus 3 are poles and 1 is a 0. The angle criterion here is even multiples of 180 degrees. So to exist a root locus or a complementary root locus on a real axis, there must exist even number of poles and zeros to the right of that point. So here in this region, we have even number of poles to the right of this region, and here also even. So these two regions we get root locus plot. And to the left of minus 3, we don't have any root locus plot. Why? Because at this region we have two poles and 1 0. That is the number is 3. Right? Now breakaway points. I will represent breakaway points. I got 3 and minus 1. Right? 3 and minus 1. So here somewhere here this is the breakaway point and minus 1. That is also here. And these two are valid breakaway points. Why? Because these are lying on root locus plot. Right? Now with this information I will draw root locus plot. So two poles exist and breakaway point exists between these two poles. That is these poles, and root locus starts at open loop pole. That is at k equal to 0 at open loop poles k equal to 0 and k equal to infinity at open loop 0 and k equal to 0 at open loop pole. So they meet at s equal to minus 1. These two poles meet at s equal to minus 1 and then they will break in at s equal to minus 1 and break out. Right? And break out. And then they have to break in at s equal to 3 also. Right? Break in, break in. Next breakaway. They have to break away at s equal to 3. And one pole will move to 0 of the open loop system and another pole will move to infinity through this asymptote, this 0 degree line asymptote. So this is the root locus plot. Okay. you want to find out gain k at this point, it is this is geometry axis crossings at this point. From the RH criteria, you can find out easily in k. And here, if you want to find out k, substitute s equal to 1, s equal to minus 1 in the magnitude criterion. Here also, substitute s equal to plus 1 in the magnitude criterion. You will get k values. In these two questions, they have asked root locus diagram only, not complementary root locus. Okay, we have drawn root locus only. These two questions. Okay, now I will draw complementary root locus also. Okay, for the second problem, I will draw complementary root locus. How it will look. So in the second problem, so in place of root locus, I'll put complementary root locus. If he asks complementary root locus diagram for this open loop system and negative feedback, okay, g of s is k 1 minus s by s into s plus 3. I will write this as minus k s minus 1 by s into s plus 3. Right? And what is the characteristic equation? 1 plus minus k s minus 1 by s into s plus 3 equal to 0. Right? From this 1 minus k s minus 1 by s into s plus 3 equal to 0. I will compare this with 1 minus k gs hs equal to 0. Right? From this gs hs equal to s minus 1 by s into s plus 3 and poles equal to 2, that is p, and zeros equal to 1, that is z. From this p minus z equal to 1, that is number of asymptotes 1 and the number of complementary root locus branches which are going to infinity also 1. That too they will reach to that too it will reach to infinity through this asymptote. Now, so what are the poles? Poles are 0 comma minus 3 and zeros are 1. What is the angle criterion here? That is important. 1 minus k gshs equal to 0, right? Now here we are drawing complementary root locus, right? So what is the definition of the complementary root locus? The forward path gain k is varied from minus infinity to 0. That is the k is negative here, right? So what I will do is I will take some k equal to minus k1. Okay, if k is varied from minus infinity to 0, then k1, what happens to k1? Minus infinity becomes plus infinity, and 0 anyway, plus 0 minus 0 both are same. So k1 is varied from plus infinity to 0, right? Now here k gs hs equal to 1. Now I will replace, here k is negative, that is why the angle will be going to change. So that is why I will replace this k by minus k1 gshs equal to 1. From this k1 gshs equal to minus 1, right? From this the angle criterion is minus 1, this is 180 degrees or odd multiples of 180 degrees. If we get the angle criterion as odd multiples of 180 degrees, then the rules are not going to be changed. Whatever the rules we have learned, those rules will not going to be changed, right? But one thing will be going to be changed here. Here the starting point is k equal to minus infinity is the starting point, right? So at k equal to infinity or minus infinity, we get 0, open loop 0. And k equal to 0, we get open loop pole. So that is the difference here, open loop pole. So complementary root locus always starts at open loop 0 and ends at open loop pole. Okay, this is the starting point and this is the ending point of complementary root locus that we have to remember. and the remaining things are all same. And break-in breakaway points also you get same, dk by ds equal to 0. What are the break-in breakaway points? We have got this, yes, 3 and -1 break-in breakaway points. So break-in breakaway points are 3 comma -1. We will check whether they are valid or not valid. And the number of asymptotes p minus z equal to 1. And what is the angle of asymptote? I think now what is the angle of asymptote? That is important. What is the angle of asymptote? 1 minus k gs. Here theta a is here odd multiples of 180 degrees. That is why 2q plus 1 180 degrees by p minus z. So 2q plus 1 180 degrees by p minus z1. So q ranging from 0 1 2 up to p minus z minus 1. We already have p minus z is 1, so only q equal to 0. So substitute q equal to 0, we will get 180 degrees. So only one asymptote exists, and that asymptote have the angle is 180 degrees. Okay. Now we'll represent all these things. No, this is 180 degree line. Okay, and this j omega axis and real axis. So what are the poles? Poles are 0 and -3. Here at 0 one pole exists, and at -3 one pole exists, and a 0 exists at j. At 0 exists at s equal to 1. At s equal to 1, first I will draw the real axis segment, because the angle criterion is even multiples of 180 degrees. So to exist complementary root locus or root locus on real axis, there must be odd number of poles and zeros to the right of that point. Okay, odd number of poles and zeros. One pole is there, 1 0 is there, and here also we have 1 0 and 2 poles. That is, the number is 3. That's it. This is the real axis. And break-in breakaway points, we will check whether they are valid or not. Okay, here we got break-in 3 and -1, represent 3 and -1. So somewhere here 3 and somewhere here -1. They are not lying on complementary root locus, so they are not valid break-in breakaway points. Okay, so break-in breakaway point does not exist. From this information, I will draw complementary root locus. Here, this is the pole here, and between two poles there is no complementary root locus. There is no path, so no break-in breakaway points exist. So here we are drawing complementary root locus, that we have to remember, right? Complementary root locus, the gain k is varied from -infinity to 0. That is, the complementary root locus always starts at open loop 0, right? So at 0, here 2 poles and 1 0 is there. That is, one more 0 is present at some infinity. So at s equal to -infinity, we have some 0 here. So the root locus starts at open loop 0. This one. Okay. And this one. 0 to pole. Right. Here the gain k is -infinity at 0. Here also it is 0, k equal to -infinity. At a pole, k equal to 0. That's it. This is the complementary root locus plot for the second question. That's it.